Every day, millions of people trust one incredible machine to fly. Jet engines power aircraft across continents and oceans. But how does a jet engine actually work? Let's journey inside one of humanity's greatest inventions. A jet engine creates thrust by pushing air backward. The reaction force pushes the airplane forward. This principle is known as Newton's third law. Modern airliners depend on powerful turbofan engines. These engines generate enormous amounts of thrust, enough power to lift hundreds of tons into the sky. The process begins at the engine intake. Hundreds of kilograms of air enter every second. The giant front fan immediately accelerates this airflow. The fan is one of the engine's most important components. Most modern thrust actually comes from the fan. Incoming air now splits into two separate paths. One stream flows around the engine core. This is called bypass airflow. The second stream enters the engine core. Now the real compression process begins. Inside the engine core, air enters the compressor section. The compressor contains rows of rotating blades. These blades spin at thousands of revolutions per minute. Each stage squeezes the air tighter than before. The pressure increases with every compressor stage. Compressed air stores enormous amounts of energy. Stationary vanes help guide the airflow efficiently. Together, rotors and stators maximize air compression. Modern engines can have more than 10 compressor stages. With every stage, the air becomes denser. The temperature of the compressed air also rises. Pressure inside the engine continues building rapidly. Engineers carefully design each blade for maximum efficiency. Even tiny improvements can save millions in fuel costs. By now, the air pressure is many times atmospheric pressure. The compressed air rushes toward the combustion chamber. This is where chemical energy becomes mechanical power. Fuel will soon be mixed with this high-pressure air. The stage is set for a controlled explosion. Next comes the heart of the jet engine combustion. Combustion chamber and turbine system. Compressed air now enters the combustion chamber. Here, aviation fuel is sprayed into the airflow. The fuel mixes evenly with the high-pressure air. Powerful igniters create the initial spark. In an instant, combustion begins. The fuel burns continuously inside the chamber. Temperatures quickly exceed 2,000 degrees Celsius. That's hotter than many volcanic lava flows. The burning gases expand with tremendous force. This creates a stream of high-energy gas. The hot gases rush toward the turbine section. Now the engine begins converting heat into motion. The gas strikes the first turbine blades. Each blade captures energy from the airflow. The turbine starts spinning at incredible speeds. A central shaft connects the turbine to the compressor. As the turbine spins, it powers the entire engine. It drives both the compressor and the giant front fan. The engine is now sustaining its own operation. But there's still enough energy left to create thrust. After passing through the turbine, the gases continue moving backward. They enter the exhaust nozzle at extremely high speed. The nozzle focuses the airflow into a powerful jet stream. Hot gases blast out the back of the engine. This backward force creates forward thrust. The aircraft begins accelerating down the runway. Meanwhile, the giant front fan produces additional thrust. In modern turbofan engines, the fan generates most of the power. Together, fan thrust and jet thrust push the aircraft forward. Speed rapidly increases as the runway disappears below. At takeoff speed, the wings generate enough lift. The aircraft smoothly leaves the ground. Jet engines continue producing thrust during the climb. Soon, the aircraft reaches its cruising altitude. Now the engines operate at peak efficiency high above the clouds. Jet engines are far more efficient than older designs. Engineers use advanced computer simulations to optimize performance. Every blade is designed for maximum airflow efficiency. Many modern fan blades are made from lightweight composite materials. These materials reduce weight while increasing strength. New engine designs also produce less noise. Lower fuel consumption helps reduce operating costs. And fewer emissions help reduce environmental impact. But what happens if an engine fails during flight? Commercial aircraft are designed with multiple layers of safety. Most airliners can continue flying safely on a single engine. Pilots train extensively for every possible emergency. Advanced sensors constantly monitor engine health in real time. From takeoff to landing, jet engines power modern global travel. And that's how a jet engine transforms fuel and air into the power of flight. If you enjoyed this journey inside a jet engine, subscribe to SciNova for more amazing science and engineering documentaries.